Hello, this is Jesse, and in this tutorial I'm going to show how to use the duet vector to insert two different proteins into the same vector. So, you are tasked with constructing an expression vector for E. coli. This expression vector must be used to carry two different proteins for expression. Below are the protein sequences. Provide a picture of your design vector. So what we're going to do first is we're going to open up reverse translation, the gene design URL that I gave you. So you just take this protein sequence and you're going to reverse translate it, and you're going to codon optimize it for E. coli. Here it is. So you can paste this here for muricin, and then I did the same thing for the beta defensin protein. So go here, copy, paste, E. coli, and then reverse translate. Same thing, copy and paste this codon optimized sequence, paste this here, and then here you can read this on your own. I'm going to be going through this step by step, but my first time doing this, I found out that the reading frames were not what I would want them to be. They do not code without adding an A on this end of the sequence and a stop codon on the other end of the sequence. My reading frames were not correct, and none of the reading frames would show this protein, this amino acid sequence. But after adjusting and adding some nucleotides to the ends, usually just this A, I was able to get this resulting protein sequence. And I added this stop codon just to stop translation, because I didn't want any additional amino acids on the end. So that's why I have these additional nucleotides at the end. One is to change what's going to be read, the reading frame, and then second is to change or to stop translation. Okay, so we have our codon optimized sequences here, and now we're going to need to get an expression vector to get this final product. So here we have the PET duet vector, PET28 or PET duet 1. I have the URL here for you. Just copy and paste this into your browser, and it should take you to this plasmid file for PET duet. So PET duet has two multiple cloning sites, and you can download this, save it, and we can use the SnapGene viewer to visualize the plasmid map, and I will be able to show you the actual two multiple cloning sites in this expression vector. SnapGene view, okay, PET duet, open this up. Notice how we have BAM, HI, and EcoRI in multiple cloning site 1, and then in multiple cloning site 2, I use KPNI, and then I use XHOI. Okay? You can double check, take these sequences for yourself, and go through Nebcutter and put them into Nebcutter and double check whether they have EcoRI or BAM-HI, and so this sequence, check if this sequence has BAM-HI or EcoRI, and then double check with the defensin nucleotide sequence whether it has the KPNI or the XHOI. Okay, double check. I've checked myself, and these sequences do not have those restriction enzyme sites. So I'm going to take this sequence here, the muricin gene sequence, and I'm going to insert it into the first multiple cloning site, MCS1, and then I'm going to take the defensin sequence here, and I'm going to insert it into multiple cloning site 2, MCS2. So first I'm going to start off with Muricin 1. So I'm going to open up Genome Compiler, and I'm going to start off with a new construction, and then I'm going to click on Restriction Ligation. I'm going to go to Next. I'm going to go to Choose a File, and I'm going to insert the PET28 or the PET duet vector. Wait for it to load, and I'm going to go to Digest, and then I'm going to use EcoRI and BAMHI. So BAM. Oh, BAM. Okay, I don't know what's going on. I'm just going to have to scroll through and find BAM. Okay, so we have BAM HI right here. And go to EcoRI. Once we find EcoRI, I'm going to click it. Okay, EcoRI. Go here. I'm going to click the 5410 base pair length. Okay, so this is the first multiple cloning site right here. BAM HI, EcoRI, and I'm going to go to Insert, and then I'm going to take my codon optimized sequence here and the additional nucleotide additions that I added to it. Copy and paste. I'm going to use this as my insert. I'm going to go on linear, and I'm going to go to generate by synthesis, and then I'm going to click enzyme, and then I'm going to click BAM for my 5' end. Oh, that's not BAM. Click on BAM. Okay, and then I'm going to go to EcoRI. EcoRI will go here. BAM HI, EcoRI, everything looks fine, no errors, and I'm going to click Next. So here's our protein, or this is the reading frame and our first multiple cloning site. So I'm going to go to Finish. I'm going to name this 2 genes. Actually, soon 2 genes. Okay. Oh, I always forget to click that. So downloads. I'm not going to save the cloning wizard. Next, what I'm going to do is I'm going to click on New Construction, and then I'm going to use the plasma that I just saved. So I'm going to find that. Okay, so I'm going to use this. So I'm going to continue on to the normal. Now I'm going to take this soon 2 genes. Remember, I just inserted the muricin gene, and I'm going to insert it, or I'm going to drag and drop. Okay, so now we still have our first gene in here. Now I'm going to go to digest, and then in this case, remember over here on the right that I'm going to be using KPNI on the 5' end and XHOI on the 3' end. So we can go to K, and then we can find KPNI, and then we can go to XHOI. Here it is. Click on this site. Notice how it's in this section now. So this is where the first multiple cloning site is located. This is where the second multiple cloning site is located. Okay, now we're going to set up our insert. Now the insert now is I'm putting beta defense in here. Copy, and then insert beta defense in, and then use insert linear synthesis KPNI. Scroll down. XHOI. Next, finish. Yes. I'm going to name it 2 genes, M for myrcene, and B for beta-defensin. Nope. Okay. Next, I'm going to open this up, and then we have 2 spaces here, one for our first gene of interest, and then second insert for our second gene of interest. I'm going to go ahead, I'm not going to use the genome compiler open reading frame. I'm going to just go ahead and just save this file. I'm going to export it as FASTA, and I'm going to put it to my desktop for now. Save, and I'm going to go straight into SnapGene Viewer, just because I prefer visualizing the open reading frames with SnapGene Viewer. If you want to do everything in Genome Compiler, that's okay. This is just preference. Desktop, 2 genes, myrcene, beta-defensin, circular annotate. Okay, so here we have our inserts here, inserts here, view. We're going to go to reading frames, view sequence. Oh, it's not letting me, for some reason, it's not letting me do this here. Okay, but in this case, this same thing happens to you. You can just click on sequence here, map, sequence. Next, we can click on, notice we have reading frames here and here. Okay, we're looking for these yellow ones, or orange ones, right here, orange. Okay, so let's go to sequence, and then we're going to look for these orange colored, and then we're going to find BAM-HI and EcoRI, and then KPNI and XHOI, and look for myrcene and look for beta-defensin. Okay, so looking for spargenine, or methionine, spargenine, isoleucine, leucine, lysine. Okay, so let's go to BAM-HI right here. So here we have methionine, spargenine, isoleucine, leucine, lysine, phenylalanine, 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 valine. So everything seems good so far. You can scroll down to where we have EcoRI. Remember, we added a stop codon here. Here it is, stop codon. Stop codon right here. So that means it should be histidine, lysine, arginine. Histidine, lysine, arginine. Okay, so we're good so far, but we're not in the clear yet. We need to double check and look for our second reading frame right here, or check for our second protein, see if it's going to be coded here. So we have methionine, arginine, and isoleucine. Okay, so let's see, that one's not it. We need to find, what is it, KPNI. That's what I'm looking for, KPNI. Here it is, KPNI. KPNI, methionine, arginine, isoleucine, histidine, tyrosine. And then we can go scroll down and then find XHOI, and then we should have lysine, lysine, arginine, arginine, lysine, lysine, arginine, arginine, and then here we have our tag with it. Here's our tag. It is in frame. So we are okay with that. See, it even tells us that it's in frame. This sequence is in frame, the S tag. So we'll have our protein sequence encoded in here, but we do have this start codon here. We might not want that to be included in our sequence, or you might be okay with it. It depends. And then, but we here have, so this would count as correct in your homework or your test. Okay, we have our sequence, we have our frame, we even have it in frame with the affinity tag. I think it's the S tag. And then we go up to the top and we should have it in frame. Our first sequence, don't know if I went over it or not, but we should have it in frame with the histidine tag. Okay, so that's the that's this tutorial, and that's the end.